What mysteries lie hidden in the place where stars are born? At first glance, the night sky appears to be a tranquil tapestry sprinkled with lights. But in the constellation of Orion, there exists a region where the universe is in constant turmoil. It is here that matter transforms, where enormous clouds of gas and dust become newly born suns, and where the ingredients for life mix in a cosmic dance. The Orion Nebula, one of the most impressive and studied wonders of the sky, is much more than a diffuse patch we can see on a clear night. It is a true garden of stars, a natural laboratory at the heart of our galaxy. Why has the Orion Nebula fascinated both professional astronomers and casual observers throughout the centuries? What makes this cluster of gas and dust so special that it seems to defy the darkness of space even to the naked eye? The answer goes beyond its spectacular beauty. Within it lie fundamental clues to understanding how a star is born, how planetary systems form, and ultimately, how our own sun came to be. It is no exaggeration to say that by studying Orion, we are looking into our own origin. In the depths of this nebula, the forces of gravity, radiation, and chemistry intertwine in processes that challenge the imagination. Here, vast amounts of hydrogen cluster together, interstellar dust swirls, and the titanic energies of young stars shape the environment. It is a setting where time and matter combine to give rise to new generations of celestial bodies. In fact, many of the elements that make up our bodies and our planet were once forged in regions like this, in explosions and cosmic collisions that seeded the galaxy with the building blocks of life. Could the Orion Nebula hold secrets yet to be revealed about planet formation and the possibility of life elsewhere in the universe? By observing and analyzing this region, science not only seeks to decipher the mechanisms of stellar creation, but also to answer one of humanity's deepest questions. Where do we come from and where are we going? Join us in discovering how this corner of the cosmos, visible from Earth and brimming with activity, has become one of the key pieces to understanding our place in the universe. What exactly is the Orion Nebula? Many have heard of it, but few understand the magnitude of this cosmic colossus. The Orion Nebula is an immense cloud of gas and interstellar dust, a true nursery of stars in the process of gestation. It is located in the constellation of Orion, one of the most recognizable in the night sky, right in the sword that hangs from the famous belt of 3 stars. But what makes this nebula so special within the vast universe? The Orion Nebula is one of the closest and most active star-forming regions to our planet. If the universe were a big city, the Orion Nebula would be like a maternity hospital, where stars are born that in a few million years will illuminate other corners of the galaxy. Why do astronomers consider it a gem? Because its location and size allow for direct observation of processes that are often hidden behind dense layers of dust elsewhere. It's like looking through a privileged window into the origins of entire solar systems. Did you know that, to the naked eye, the Orion Nebula may seem like just a small diffuse spot in the sky, but in reality, it is a gigantic cosmic factory. Its brightness is due to the intense radiation from young stars that excite the gas around them, causing it to emit light. Thus, the nebula not only reflects stellar birth, but also illuminates its surroundings with a spectacle of colors and shapes. In astronomical terms, it is an emission nebula, meaning its glow comes from the energy released by the gas atoms within. The importance of the Orion Nebula goes far beyond its beauty. It is a natural laboratory for studying how stars and planets arise. That's why scientists observe it with obsessive attention, searching for clues about our own origin. Is it possible that in the past, our Sun and Earth were born in a similar environment? The answers offered by the Orion Nebula not only satisfy human curiosity, but also connect us to the deeper history of the cosmos. How far is the Orion Nebula from us? At first glance, it may seem like a simple blot in the sky, but its distance is much greater than most imagine. Astronomers have calculated that the Orion Nebula is approximately 1,300 light-years away from Earth. That means the light we see today left the nebula when telescopes, electricity, and even the printing press did not yet exist on our planet. Every time we look up at Orion, we are actually looking into the past, observing a cosmic postcard sent over a millennium ago. But what exactly does a light year mean? A light year is not a measure of time, but of distance. It is the distance that light travels in a year, which is about 9.5 trillion kilometers. So, if we multiply that figure by 1300, we get a number so large that it is almost impossible to imagine. It's as if we wanted to cross the entire planet millions of times, and still, we wouldn't reach the Orion Nebula. This immense separation makes the nebula one of the closest objects within the vast regions of star formation. Yet it remains incredibly far in human terms. The accuracy in measuring this distance was not always so clear. For centuries, astronomers could only make estimates based on the brightness and apparent size of the nebula. With the advent of modern technology, especially astrometry and space telescopes, the calculations were refined. Methods like parallax, which compares the apparent position of the nebula from different points in Earth's orbit, allowed for much more accurate figures. Surprisingly, even a small variation in distance implies huge differences in our understanding of the nebula, from its actual size to the number of stars it can harbor. Why is it so relevant to know the exact distance to the Orion Nebula? Knowing how far it is allows us to calculate its true size, estimate the amount of energy it emits, and better understand the star formation process within it. Additionally, it helps us locate it within our own galaxy, the Milky Way, and compare it with other similar regions. Ultimately, distance is not just another piece of data. It is the key to unlocking the secrets of the cosmic garden where new stars are born.
If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey.
How big is the Orion Nebula really? Although from Earth we see it as a small diffuse spot in the sky, its size challenges our imagination. If we could place it in our solar system, the Orion Nebula would span a distance several times greater than that which separates the Sun from Pluto. Its diameter is estimated to be about 24 light years, which means that light, traveling at nearly 300,000 kilometers per second, would take more than 2 decades to cross it from one end to the other. To put it in perspective, if a commercial airplane wanted to cover that distance, it would need more than 40 million years. But how is this gigantic cloud of gas and dust organized? The Orion Nebula is not a uniform sphere. Its structure is complex and dynamic, formed by regions of bright gas, dark filaments, and voids carved by the action of stellar winds. At its center is a cavity, like a bubble sculpted by the powerful radiation of the young stars it hosts. Around this central bubble, materials swirl and condense into knots and columns, creating cosmic landscapes that seem sculpted by an invisible force. Within the nebula, there are different layers and substructures. One of the most notable is the so-called ionized core, a region where the ultraviolet radiation from newly born stars strips electrons from hydrogen atoms, causing the gas to glow intensely. Beyond the core, we find areas of denser dust that block light and create dark silhouettes, as if they were storm clouds suspended in interstellar space. These contrasts between bright and opaque regions are the result of a delicate balance between gravity, gas pressure, and radiation push. And what happens at its edges? Here, the interstellar material begins to mix with the surrounding space. The shockwaves generated by past explosions and stellar winds sculpt whimsical shapes, while dense clouds provide shelter for future generations of stars. The Orion Nebula, as a whole, is like a vast cosmic garden in constant change, where matter is recycled and transformed under the relentless laws of physics. Every corner of this gigantic structure witnesses energetic and violent processes, but also the calm necessary for the birth of new stars and planets. What ingredients make up the mysterious cosmic broth of the Orion Nebula? To answer this, let's consider the recipe that kickstarts many stars and planets. The Orion Nebula is, above all, a gigantic cloud of gas and dust. But what is that gas really made of? The most abundant element is hydrogen, the fundamental building block of the universe. This element accounts for the majority of the mass of the nebula and is the main fuel for the formation of new stars. Alongside hydrogen, helium ranks second in abundance, although in much smaller quantities. Are there other elements besides hydrogen and helium? Of course. Although in tiny proportions, the Orion Nebula also contains oxygen, carbon, nitrogen, sulfur, silicon, and iron. These elements, known as metals in astronomical terms, play a crucial role in the formation of complex molecules and in the chemistry that may later give rise to planets and, perhaps, to life. Oxygen and carbon in particular are essential for the emergence of organic molecules, the basic building blocks of life as we know it. What about the molecules? The Orion Nebula is famous for its richness in molecules, some as simple as carbon monoxide, and others much more complex, like water, ammonia, and even prebiotic organic molecules. Imagine it as a kind of natural laboratory where chemical reactions occur on unimaginable scales. The conditions within the nebula, with intense radiation and varying temperatures, favor the constant formation and destruction of these molecules, creating a dynamic and surprising environment. But how does this chemical composition affect the star formation process? The presence of interstellar dust, made up of tiny grains of silicates, ices, and carbon, is fundamental. This dust not only obscures parts of the nebula, but also acts as an incubator. It protects fragile molecules from the most intense radiation and allows the gas to cool, facilitating the gravitational collapse necessary for new stars to be born. Thus, the Orion Nebula is not just a collection of gases, but a true chemical garden, where the ingredients of the universe mix and transform, preparing the ground for the creation of new worlds. How was one of the most fascinating objects in the sky discovered? The Orion Nebula, although it dazzles us today with its colors and shapes, has been part of human history long before telescopes existed. Ancient peoples, while observing the constellation of Orion, noticed a kind of fuzzy spot right in the hunter's sword, visible even to the naked eye on clear nights. But when was it recognized that this spot was not simply a diffuse star, but a gigantic cloud of gas and dust? Let's go back to the 17th century. In 1616, the French astronomer Nicolas-Claude Fabry de Peiresc pointed a rudimentary telescope at Orion and described the nebula for the first time as a different object, an extensive and luminous region in the sky. Shortly after, in 1659, the astronomer Christian Huygens studied the nebula in greater detail and published the first known drawing of the region, revealing internal structures that astonished the scientific world of the time. Huygens, in fact, gave it its name, the Orion Nebula. Over the following centuries, astronomers like Charles Messier and William Herschel contributed to a better understanding of this celestial object. Messier included it in his famous catalogue in 1769, assigning it the number 42. Herschel, for his part, observed the nebula with more powerful telescopes and suggested that it might be a glowing matter, a revolutionary idea for the 18th century. These discoveries marked the beginning of a new era in astronomical observation, where the Orion Nebula became a natural laboratory to explore the birth of stars. But what mysteries arose from studying it more deeply? During the 19th century, advances in spectroscopy allowed scientists to analyze the light coming from the nebula. It was then that William Huggins detected unknown spectral lines, suggesting the presence of exotic chemical elements. This finding opened the door to a new branch of astronomy, astrophysics. The Orion Nebula, far from being just a spot in the sky, transformed into a window to the origin of stars and the fundamental processes of the universe. Thus, the story of its discovery is also the story of human progress. From simple naked-eye observations through the first telescopes to the development of modern analytical techniques. Each step along the way has brought humanity closer to a better understanding not only of the Orion Nebula, but of our own place in the cosmos. What is the mystery that makes the Orion Nebula, beyond its scientific splendor, have fascinated humanity since ancient times? Since the dawn of civilization, the night sky has been a canvas filled with stories, and Orion occupies a central place in many of them. The hunter Orion, whose figure dominates the sky, is not just a constellation. He is a recurring character in tales of gods, heroes, and titans. But what role does the nebula play in these stories? Although our ancestors could not see the nebula with the clarity that today's telescopes allow, the region where it is located was already a source of myths and legends, perceived as a mysterious and powerful place. In Greek mythology, Orion is a giant hunter, son of Poseidon, whose story intertwines with gods and mythical creatures. It is said that he was placed among the stars by Zeus, and his belt, where the nebula hides, is one of the most identifiable features of the sky. Why did this region attract so much attention? For the ancients, the alignment of the stars and the diffuse glow in the center of the belt could be interpreted as celestial signs, portals, or divine weapons. Some cultures believed that souls were born there, an idea that, interestingly, approaches the actual function of the nebula as a cradle of stars. Not only the Greeks were inspired by Orion. In Egyptian mythology, Orion's belt was associated with Osiris, the god of resurrection and the afterlife. The builders of the Giza pyramids aligned these monuments with the stars of the belt, believing that this facilitated the pharaoh's passage to the beyond. Could the faint light of the nebula, barely visible to the naked eye under dark skies, have been interpreted as a sign of transcendence? For the Egyptians, the sky was a sacred map, and every twinkle had meaning. In America, indigenous peoples also wove their own stories around Orion. The Mayans saw in that region a place of creation, a celestial fire where gods are born. For Australian Aboriginals, the figure of Orion represented hunters chasing celestial prey, and the nebula, although subtle, was part of the narrative of eternal hunting. It is surprising how cultures separated by oceans coincided in associating this area of the sky with birth, death, and renewal. Why did so many cultures see in Orion and its nebula something sacred, a threshold between worlds? Perhaps because in the vastness of the cosmos, certain patterns and glimmers invite the imagination to seek meaning and connection. The Orion Nebula, even without being fully visible, has been an inexhaustible source of myths and symbols, reminding us that science and mythology have shared, for millennia, the admiration and wonder for the universe. Is it possible to observe a nebula with the naked eye, without the need for telescopes or binoculars? Surprisingly, the Orion Nebula is one of the few exceptions in the sky. During clear winter nights in the northern hemisphere, simply look up at the constellation of Orion to discover a small diffuse glow beneath the line of 3 aligned stars. That glow, almost ghostly, is the Orion Nebula itself, visible to the naked eye as a faint and blurry patch. Not all celestial objects can be seen without assistance, but this nebula offers a spectacle that anyone can seek out, even from small towns or the outskirts of the city. What makes the Orion Nebula so special among the thousands of objects in the sky? The answer lies in its extraordinary brightness and size. While most nebulae hide behind a veil of darkness, Orion shines thanks to the young and energetic stars that illuminate it from within. It's as if a gigantic cosmic lantern is lit in the middle of the night, piercing through the interstellar dust and gas. That's why even our eyes, which are not designed to capture such faint light, can perceive it without sophisticated instruments. Many wonder what the best time is to look for the Orion Nebula. The key is to choose nights that are as dark as possible, away from the light pollution of large cities. During the months of December to March, Orion rises high in the sky after sunset, making it easier to observe. If you manage to identify the famous Orion's belt, those 3 stars in a straight line, you just need to look right below them. There you will find another row of smaller stars, and in the center, the diffuse glow of the nebula. It's like finding a hidden treasure in plain sight, a celestial jewel that has fascinated humanity for generations. Why don't we see it with the same colors and details that astronomical photographs show? This is because our eyes are not very sensitive to faint light and colors in the dark. What for the cameras of large telescopes is a festival of pinks, greens, and blues, for us is just a grayish or whitish cloud. However, that subtle patch in the sky is direct proof that, even with the most basic technology, our own eyes, we can connect with the birth of new stars over 1,000 light-years away. Thus, the Orion Nebula invites anyone to explore, to marvel, and to remember that the universe always offers mysteries within sight. What happens when we observe the Orion Nebula through a telescope? For centuries, astronomers have used different instruments to try to decipher its secrets. To the naked eye, the nebula appears as a diffuse blot in the sky, but when looking through a small telescope, that blot transforms into an object with shape, structure, and even a certain greenish or bluish glow. It's like looking at a blurry painting and suddenly starting to distinguish brushstrokes and details that once seemed invisible. With amateur telescopes, the experience changes radically depending on the aperture and optical quality. A modest telescope allows you to see the irregular edges of the nebula and, on dark sky nights, reveals the famous trapezium cluster, a group of young stars at the heart of the cloud. Why is the trapezium so important? Because its intense light illuminates the surrounding gas and dust, making the nebula shine and showcasing the drama of star formation in action. When we move to more powerful telescopes, like those found in professional observatories, the view becomes even more spectacular. Filaments and internal structures are appreciated, resembling rivers of gas flowing and colliding with each other. The colors captured in long-exposure photographs are not just visual beauty, but clues about the composition and temperature of the materials. Hydrogen glows in reddish tones, while oxygen and sulfur contribute green and blue hues. Did you know that, thanks to these details, astronomers can map regions where new stars are born, almost as if they are viewing a cosmic garden in full bloom? But the real revolution came with space telescopes like Hubble, and more recently, James Webb. By observing in wavelengths invisible to the human eye, these instruments reveal hidden layers of the nebula. In the infrared, for example, it is possible to see through the densest regions of dust and discover protostars and protoplanetary disks in the process of formation. Thus, each telescope, from the simplest to the giant space ones, offers a different window into the Orion Nebula, allowing us to better understand how stars and planetary systems are born in our nearby universe. What other secrets might be waiting to be discovered, hidden in the brilliant glow of Orion? What makes an astronomical image truly iconic? In the case of the Orion Nebula, the answer lies in the combination of mystery, beauty, and scientific data revealed by those photographs. When astronomers pointed the Hubble Space Telescope at this stellar nursery, they captured one of the most famous images in the universe. That photograph, showcasing glowing clouds of gas and colossal pillars of dust, allowed us to glimpse details that were previously inaccessible. It was as if, for the first time, a direct window opened into the process of star birth. But how do these images manage to show us so much? The key is that modern telescopes capture light at different wavelengths, beyond what the human eye can perceive. For example, the James Webb Space Telescope, using its infrared vision, has managed to penetrate the veil of dust that hides the most active areas of the nebula. Thus, it reveals a scene filled with protostars and protoplanetary disks, where matter gathers and spins, preparing to form new worlds. These images are not only beautiful, but also scientific tools that allow astronomers to study the evolution of stellar systems. Did you know that some of the structures appearing in the images of the Orion Nebula have been given proper names? The gas bubbles and the so-called proplyds, short for protoplanetary disks, have become true protagonists. In the most detailed portraits, these objects appear as small bright dots surrounded by dark halos, as if they were fireflies trapped in a cloud. Each one of them is a promise. They could be giving rise to future solar systems similar to ours. The latest images have allowed us to observe dynamic phenomena, such as jets of gas expelled at incredible speeds by newly born stars. Why do these images captivate us so much? Beyond their spectacular nature, they remind us that the universe is in constant change and that even thousands of light years away, processes are unfolding that have a direct connection to the origin of life and the formation of planets. It's like contemplating, in a single photograph, the history of the past, present, and future of our cosmos. What makes the Orion Nebula one of the most fascinating natural laboratories in the universe? The answer lies in its role as a star formation region, a true cosmic nursery where new stars are born almost daily. In this gigantic interstellar garden, the conditions are ideal for gas and dust to concentrate and give rise to newly formed suns. If one could observe this process over the centuries, they would see the nebula constantly transforming and renewing itself, like a landscape in perpetual spring. But why is the Orion Nebula so special for star formation? Its relative proximity to Earth, about 1,300 light-years away, makes it the closest massive star nursery to our planet. This allows astronomers to study in great detail the stellar birth processes that would otherwise be invisible or too distant. The nebula contains several thousand young stars in full gestation, many of them clustered together and surrounded by dense clouds of gas that act as natural incubators. Is this the only place where stars are born? Of course not. However, the Orion Nebula stands out for its dynamism. Here, gravity competes with radiation pressure, and waves of energy from newly formed massive stars shake the environment, stimulating the collapse of new areas of gas and dust. This cycle of destruction and creation resembles an ecosystem on Earth, where wildfires can give way to new generations of life. The Orion Nebula is, in essence, a large-scale star factory. Housing everything from protostars to forming planetary systems, it offers a privileged window to understand how our own sun came to be and how likely other systems like ours are forming in different corners of the galaxy. Asking what other secrets this cosmic nursery holds is to open the door to the deepest mysteries of our stellar origins. How does a star form in the heart of a nebula like Orion? The process begins in the deep silence of a gigantic cloud of gas and dust, known as a molecular cloud. These clouds, cold and dark, contain the raw material that will give rise to new stars. But what triggers a region of that cloud to begin collapsing? Often an external disturbance, such as a shockwave from a nearby supernova or the pressure exerted by the wind from massive stars, compresses certain areas of the cloud. At those points, gravity starts to win the battle, pulling more and more material toward the center of the region. As gravity concentrates the gas and dust, the density and temperature in the core increase dramatically. It's as if the matter begins to squeeze into an ever smaller and hotter ball. This contracting core is called a protostar. However, at this point, we still cannot call it a star in the full sense. It does not yet shine through nuclear fusion. So what happens next? The temperature continues to rise until, finally, in the center of the protostar, millions of degrees are reached. It is at this critical moment that hydrogen atoms, the most abundant element, begin to fuse, releasing an immense amount of energy. A star is born. But stellar birth is not a clean or instantaneous process. Around the protostar, the leftover material forms a rotating disk of gas and dust. This disk, in addition to feeding the growing star, is the cradle of future planets and other smaller bodies. Frequently, the young star expels powerful jets of material along its poles, as if trying to rid itself of excess energy and matter. These flows, known as bipolar jets, are unmistakable signs that the star formation process is underway. Why is it so important to understand the process of stellar birth? Because every star we see in the sky, including our own sun, went through a similar stage. The life cycle of stars begins in these cosmic nurseries, where gravity and atomic physics intertwine to transform simple clouds of gas into the celestial bodies that illuminate the universe. Thus, every time we look at a nebula like Orion, we are observing the natural workshop where, over millions of years, matter reinvents itself and gives rise to new generations of stars and planets. What is the true protagonist in the birth of a star? The answer, although it may seem simple, is fundamental: hydrogen. This element, the most abundant in the universe, is the essential raw material in the vast cosmic laboratory that is the Orion Nebula. Imagine hydrogen as the tiny seeds of a garden. Without them, new stars could never bloom. But how does hydrogen transform a dark, cold cloud into a brilliant stellar nursery? It all begins with cold, dense clouds, primarily made up of hydrogen atoms. These clouds, drawn by the force of gravity, start to collapse in on themselves. Hydrogen, being so light and abundant, is the first to respond to the gravitational call. As the cloud compresses, the hydrogen atoms get so close that the temperature rises spectacularly. Why is this so important? Because when the temperature exceeds 10 million degrees, something extraordinary happens: nuclear fusion. At the heart of the protostar, hydrogen nuclei begin to fuse, releasing an immense amount of energy. This process, known as nuclear fusion, is what literally ignites a star. One could say that hydrogen is both the fuel and the spark at the same time. Without this gas, the Orion Nebula would simply be an inert cloud, incapable of giving birth to new stars. It's fascinating to think that the light of every young star shining in Orion is, in essence, the result of the energetic dance of millions and millions of hydrogen atoms. But the role of hydrogen doesn't end there. The interaction between the ultraviolet radiation from the newly born stars and the surrounding hydrogen causes this gas to emit a characteristic light known as H-alpha emission. This luminescence is responsible for the iconic reddish glow of the Orion Nebula, marking the regions where star formation is most intense. Thus, hydrogen not only participates in the birth of stars, but also acts as the artist that paints the stage where this cosmic spectacle occurs. Therefore, understanding the role of hydrogen is to understand the very essence of stellar creation in our galaxy. Have you ever considered what role interstellar dust plays in the creation of new worlds? It is often thought that dust is merely an obstacle to astronomers' views, but in reality, it is one of the most important players in the stellar birth cycle. In the Orion Nebula, interstellar dust not only obscures regions, but also serves as the fundamental raw material for planetary systems. Without this dust, there would be no planets, moons, or asteroids. What is this dust made of? Unlike the dust that accumulates on a shelf, interstellar dust is composed of tiny grains of silicate, carbon, water ice, ammonia, and other compounds. These incredibly small grains can be compared to smoke particles, but they are essential because they act as nuclei on which other materials deposit and, over time, can grow into much larger objects. But how does dust contribute to the formation of planetary systems? Around the young stars in the Orion Nebula, gas and dust begin to clump together due to gravity. This material forms rotating disks known as protoplanetary disks. It is within these disks that interstellar dust starts to stick together, grain by grain, colliding and merging into increasingly larger fragments. This process, which seems simple, is the first step toward planet formation. Without dust, gas could not condense enough to create solid bodies. Furthermore, dust has another crucial role. It protects and cools. Dust grains absorb ultraviolet radiation and scatter it, creating shadowed areas where molecules can survive, and temperatures drop low enough to allow the formation of complex molecules, many of which are considered essential for life as we know it. Thus, interstellar dust is both architect and shield, facilitating the creation of planets and, potentially, the conditions for the emergence of life. It is fascinating to think that everything we know, from planets to our own bodies, was once interstellar dust. Each grain in the Orion Nebula is, in essence, a seed of the future. Who could imagine that the humblest material in the cosmos has the power to build entire worlds? In the pulsating heart of the Orion Nebula lies a star cluster that has fascinated astronomers for centuries. The trapezium. Why does it have such a peculiar name? The answer is simple, yet surprising. The main stars of this cluster form a geometric shape in the sky that closely resembles a trapezoid, that four-sided figure reminiscent of circus swings. But what makes this group of young stars so special? The trapezium is composed of 4 bright stars that are actually multiple systems. Some of them are not a single star, but 2 or even more, orbiting around each other. These stars are true young giants. They possess masses much greater than that of the Sun and a luminosity capable of outshining thousands of ordinary stars. Can you imagine what it means to be born in such an energetic environment? The intense ultraviolet radiation emitted by these stars is so powerful that it transforms everything around them. Their light is responsible for making the gases of the nebula shine and sculpting the cloud of dust and gas into whimsical shapes. But what role does the trapezium play in the star formation of the Orion Nebula? It is much more than just a simple collection of bright celestial bodies. These stars act as a cosmic engine. Their radiation and stellar winds influence the entire environment, triggering the formation of new stars in nearby regions while simultaneously preventing gas from accumulating in other places. It's like a garden where some flowers help others grow, but also limit the space for new seeds. Thus, the trapezium regulates the rhythm of star birth in this gigantic cosmic nursery. A little-known curiosity is that, despite their youth, these stars live at a dizzying pace. Their enormous mass condemns them to a short and explosive life in astronomical terms. While a star like the Sun can shine for billions of years, the stars of the trapezium will exhaust their fuel in just a few million years. In doing so, they will leave an indelible mark on the nebula, enriching the space with heavier elements and contributing to the future evolution of the region. The trapezium, then, is not just the heart of the Orion Nebula. It is the heartbeat that drives the cycle of birth and death of stars in one of the most fascinating stellar nurseries in the universe. What makes the Orion Nebula so special as a star nursery? Within it, some of the youngest and most massive stars in the galaxy are born. True cosmic giants that transform everything around them. But how do such colossal stars form amidst clouds of gas and dust? The answer lies in the enormous amount of available material, dense cold regions that, under the influence of gravity, begin to collapse, accumulating mass until they reach unimaginable temperatures and pressures. It is in that extreme environment where the most massive stars emerge, bodies that can be up to 40 times heavier than our Sun. Why are young, massive stars so relevant in the stellar life cycle? Because they act like engines that ignite and sculpt their surroundings. Once these stars ignite, they release enormous amounts of energy in the form of ultraviolet light and powerful stellar winds. This torrent of radiation not only illuminates the nebula, but also shapes the gas and dust, carving out cavities and generating new shockwaves that, in turn, can trigger the birth of other stars. Thus, each massive star becomes a kind of cosmic sculptor, molding the nebula and determining the fate of future stellar generations. Have you ever wondered how long a star of this size lives? Paradoxically, the greater its mass, the shorter its existence. While a star like the Sun can shine for billions of years, the young, massive stars of Orion burn their fuel in just a few million years. They have brief but intense lives. During that short span, their activity is so violent that they can trigger supernova explosions, seeding the surrounding space with heavy elements essential for planet formation and, eventually, for life. Moreover, these stars are not usually alone. Many of them cluster together, interacting with each other and competing for the surrounding material. Their gravitational forces, radiation, and winds intertwine, creating a chaotic yet fundamental ballet for the evolution of the nebula. Each of these young, massive stars is both a spark and a destructive force, capable of shaping their environment and marking the future of an entire corner of the galaxy. In the Orion Nebula, witnessing the birth and life of these stars is peering into the creative engine of the universe. What exactly happens in the depths of a nebula like Orion when a star is about to be born? In that chaotic and dense environment, clouds of gas and dust cluster together as if gravity were weaving an invisible fabric that traps and condenses material at certain privileged points. Thus, in the heart of these clusters, protostars emerge, objects still shrouded in material, too young to shine on their own, but already marked with a stellar destiny. These protostars are cosmic embryos, accumulating mass and energy until they reach the necessary temperature and pressure to trigger nuclear fusion within. But how do planetary systems form from this process? Around many protostars, a fascinating phenomenon is observed: protoplanetary disks. These disks are enormous structures of gas and dust that rotate around the forming star like a ring of ingredients ready to be mixed. If we could shrink down to the size of a dust particle and travel through that disk, we would see a landscape of collisions, agglomerations, and constant impacts. Materials begin to stick together, forming increasingly larger bodies, from tiny grains to rocks and eventually planetary embryos. Why are these protoplanetary disks so important? Because they are the natural laboratory where planets, moons, and other minor bodies are born. In the innermost regions of the disk, the heat is so intense that only rocky planets can form, while in the outer regions, where the temperature drops, ices and gases accumulate, giving rise to giant planets. This process, which lasts only a few million years, is fundamental to understanding the origin of systems like ours. Can we see this process in action? Thanks to advances in astronomical observation, we now know that in the Orion Nebula, there are hundreds of protostars surrounded by protoplanetary disks. Some of these disks show clear gaps and structures, evidence that there are already forming bodies that have begun to clear their orbits. Each of these systems represents a different story, a natural experiment that allows us to peek into the distant past, when even our own Sun and Earth were just a possibility amidst dust and gas. Thus, the Orion Nebula is not just a visual spectacle, but a true workshop of cosmic creation. What happens when a star is in the process of being born? In the heart of the clouds of gas and dust, where gravity begins to compress matter, astonishing phenomena such as jets and bipolar outflows emerge. Have you ever wondered why some newly born stars seem to shoot out jets of material at astonishing speeds, as if they were cosmic sprinklers? This curious behavior is, in fact, one of the clearest signs that a new star is in full development. During the early stages of formation, a protostar is still surrounded by a dense envelope of gas and a rotating disk of material. As the young star accumulates mass and grows in its core, some of the gas and dust falls toward it, but another part is violently expelled from the poles. This material is ejected in the form of narrow, high-speed jets, known as bipolar jets. These jets can travel distances of several light years and reach speeds of hundreds of kilometers per second. It's as if the newly born star needs to shed some of its baggage to stabilize itself. But what drives these powerful jets? The explanation lies in the interaction between the intense magnetic fields of the protostar and the surrounding material disk. As the gas spirals inward toward the stellar core, the magnetic field lines channel some of that material toward the poles and expel it in opposite directions. This is how bipolar outflows are formed, which not only expel matter, but also clear the immediate environment of the star, allowing light to finally escape from the natal nebula and making the protostar visible. These jets are not only spectacular, but also play a fundamental role in the evolution of the star and its surroundings. As they pass through, the jets carve out cavities in the gas cloud, shape the structure of the nebula, and trigger shock waves that can compress nearby regions, encouraging the birth of new stars. Could we say that, in some way, a young star helps to seed the space around it, giving rise to future stellar generations? Jets and bipolar outflows are undoubtedly some of the most dynamic and visual processes in the Great Garden where stars are born. What exactly are those small, dark, and mysterious globules that astronomers have found scattered throughout the Orion Nebula? If you've ever wondered how planets can arise in such a chaotic environment as a stellar nursery, the answer may lie in these structures, the gas globules and proplyds. Gas globules are compact and dense clouds of interstellar material, primarily composed of molecular hydrogen, dust, and traces of other elements. At first glance, they may seem like simple dark spots, but in reality, they are true cosmic laboratories where matter concentrates and can give rise to new stars and planetary systems. Now, what makes proplyds so special? The term proplyid comes from the English protoplanetary disk. These are disks of gas and dust that surround young stars and represent the early stages in planet formation. One could compare a proplyd to a cosmic version of an incubator, where the basic ingredients of the universe mix and evolve to form planets, moons, and other celestial bodies. The fascinating part is that, thanks to the intense radiation from nearby stars, these disks illuminate and become visible, allowing astronomers to directly observe a process that, in our own solar system, occurred billions of years ago. But why do we find so many proplyds in the Orion Nebula? The answer lies in the intense star formation activity that characterizes this region. Powerful, young, massive stars emit large amounts of ultraviolet radiation, sculpting and shaping the gas globules and proplyds while making them shine and revealing them to our telescopes. However, this radiation can also have a devastating effect. If it is too intense, it can disperse the material of these disks before they manage to form planets, a delicate balance between destruction and creation. Proplyds have revolutionized our understanding of the birth of planetary systems. Observing them in Orion is like peeking into a cosmic workshop in full operation, where matter transforms and new possibilities for life emerge. Each proplyd is a potential solar system in gestation, a promise of worlds that do not yet exist. What secrets do these disks of dust and gas hold? How many of them will go on to form planets, and how many will fade away under the pressure of nearby stars? In the Orion Nebula, gas globules and proplyds show us that the creation of planets is a process as fragile as it is grand, and that even amidst chaos, the universe finds ways to create new beginnings. What turns a nebula into a brilliant spectacle or a dark mystery in the sky? The answer lies in the interaction between the light of young stars and the interstellar material surrounding them. Within the Orion Nebula, we find both dazzling regions that look like lit lanterns in the cosmos and opaque, shadowy areas that hide secrets within. But what accounts for these marked differences? Bright nebulae, like the H2 regions within Orion, glow because the gas, primarily hydrogen, is energized by the intense ultraviolet radiation from young, hot stars. This radiation excites the hydrogen atoms, which then emit visible light. It's as if the new stars are painting their surroundings with luminous brushstrokes, revealing shapes and colors that exist nowhere else in the universe. These bright areas not only gift us spectacular images, but also indicate where new stars are being born. In contrast, dark nebulae challenge our curiosity. These regions are made up of dense clouds of dust and gas that block background light, creating black silhouettes against the interstellar glow. Think of it like looking at a dense cloud hiding the sun in the sky. Where there is dust, light cannot pass. These dark areas may seem empty, but they are actually true cosmic laboratories where material condenses and can give rise to future generations of stars and planets. In many cases, within these shadows lie protostars and protoplanetary disks, invisible to the naked eye. Did you know that often the darkest regions are also the most active in terms of star formation? Although they may seem like quiet places, violent and transformative processes are happening inside them. Dust not only conceals, but also protects forming stars from intense external radiation, allowing gravitational collapse to continue until new suns ignite. That's why studying both bright and dark areas is essential to understanding the life cycle of stars. The coexistence of bright and dark nebulae in Orion is palpable evidence of the complexity of stellar nurseries. While light reveals and celebrates the birth of new stars, darkness hides and safeguards the ingredients of cosmic creation. Thus, the Orion Nebula becomes a fascinating mosaic, where light and shadow work together to build the most astonishing landscapes of the universe. What role does ultraviolet radiation play in the stunning spectacle of the Orion Nebula? While we often associate ultraviolet light with the sun or even special lamps, in the depths of space, this type of radiation is a transformative force. The youngest and most massive stars of the nebula, especially those in the trapezium cluster, emit enormous amounts of ultraviolet radiation. But what effect does this radiation have on the vast sea of gas and dust surrounding them? When ultraviolet radiation collides with the hydrogen clouds of the nebula, a fascinating phenomenon occurs. Hydrogen atoms lose their electrons, a process known as ionization. It's as if ultraviolet radiation awakens the gas, causing it to glow with a characteristic light. In fact, that unmistakable glow that makes the Orion Nebula so famous is largely a direct result of the action of ultraviolet radiation on hydrogen. Without this interaction, the nebula would be dark and silent, almost invisible to our eyes. But ultraviolet radiation not only illuminates, it also sculpts and transforms. How does it achieve this? Imagine the nebula as a garden of ice that, when exposed to heat, begins to melt and change shape. Similarly, ultraviolet radiation erodes and evaporates gas and dust in certain regions, shaping complex structures and creating clear boundaries between bright and dark areas. This bombardment of energy can even slow down the formation of new stars in some areas, while in others it triggers compression waves that can lead to the birth of new stellar generations. Could ultraviolet radiation have even deeper effects? Scientists believe that this type of radiation also influences the chemistry of protoplanetary disks, those rings of material surrounding newly born stars. The intense energy can break complex molecules and create new ones, forever changing the fate of forming planets. Thus, ultraviolet radiation acts as a kind of conductor, guiding the evolution and destiny of an entire cosmic ecosystem. In the Orion Nebula, ultraviolet light not only reveals the spectacle but also creates it. What happens when a newly born massive star begins to shine brightly at the heart of a nebula? The answer lies in two fundamental phenomena that transform the environment: evaporation and photoionization. Inside the Orion Nebula, young stars emit enormous amounts of ultraviolet radiation, much more powerful than visible light. This radiation directly impacts the surrounding gas and dust, triggering physical processes that shape the nebula in surprising ways. Photoionization is a process in which ultraviolet radiation strips electrons from hydrogen atoms, turning neutral gas into plasma, that is, a gas of charged particles. Why is this so important? Because the region surrounding the stars becomes luminous and bright, as if the nebula itself comes to life and begins to shine from within. This radiation also creates a clear boundary between the ionized zone and the cold gas, a kind of invisible skin that delineates the advance of chemical reactions. Thus, photoionization not only illuminates the nebula, but also determines where new stars and planets can be born. Now, evaporation in this context is not like what happens when water boils in a pot. Here, evaporation means that intense radiation and stellar winds heat and disperse the gas and dust of the nebula, gradually carrying them into outer space. It's as if a scorching breeze is constantly blowing, breaking down the smaller structures and revealing the core of the nebula. This process is crucial because it regulates the amount of material available to form new stars. If evaporation is too rapid, some protostars may be left exposed before they have time to grow, limiting their development. Can this effect halt planet formation? In some cases, yes. Radiation and evaporation can destroy protoplanetary disks, those structures of gas and dust where planets emerge. However, they can also trigger waves of star formation by compressing gas in certain regions, as if the fire of some stars ignited the spark for the birth of others. In the Orion Nebula, the struggle between creation and destruction is constant, and photoionization along with evaporation play the role of cosmic sculptors, shaping a scenario where stars and planets fight to carve their way through the intense energy that dominates their environment. What happens when a newly born star begins to blow strongly in its surroundings? In the Orion Nebula, young massive stars launch powerful stellar winds into space, streams of charged particles moving at speeds of hundreds or even thousands of kilometers per second. This wind, although invisible to the naked eye, is capable of sculpting the gas and dust around it, generating complex and bubbling shapes that keep the nebula in constant transformation. It is not an exaggeration to compare stellar wind to the breath of an artist shaping cosmic clay. Instead of hands, it is energetic particles that shape this celestial landscape. To what extent can these winds change the fate of the nebula? Their impact is profound. The gas and dust closest to the massive stars are pushed and dispersed, creating cavities and hollow structures known as bubbles or wind cavities. These emptied regions can reach impressive sizes, opening spaces amidst the dense interstellar material. But it's not just about emptying areas. By compressing the gas at the edges of these bubbles, stellar wind can trigger the birth of new stars, generating a continuous cycle of star formation. Thus, the destructive and constructive power of stellar wind intertwines, altering the balance of the nebula. Why is this process so important? Stellar wind largely determines the evolution of gas clouds within the Orion Nebula. While it can disperse material and halt star formation in certain regions, it can also trigger new waves of star births in other areas by compressing the gas and increasing its density. It's as if the nebula itself is constantly reorganizing, guided by the energy of its youngest and most powerful stars. This phenomenon not only affects Orion, but is key to understanding the life and death of molecular clouds throughout the galaxy. Are there long-term consequences? Undoubtedly. Over time, stellar winds can sweep large amounts of material out of the nebula, limiting the number of stars that can form in the future. Additionally, these winds enrich the surrounding space with heavy elements forged inside stars, paving the way for the formation of future stellar and planetary generations. Thus, stellar wind not only sculpts and shapes, but also sows the ingredients for new solar systems, revealing the essential role of this phenomenon in the dynamics of the universe. What role do supernovae play in the history of the Orion Nebula? If we think of the life of stars as a cycle, supernovae represent the explosive end of the most massive stars. But what happens when one of these giants explodes? The answer is surprising. Instead of disappearing without a trace, supernovae release enormous amounts of heavy elements into space, such as oxygen, carbon, iron, and calcium, materials that did not exist in the primitive universe. Thus, each supernova is like a cosmic alchemist, enriching the environment with fundamental ingredients for life and the formation of new generations of stars and planets. In the Orion Nebula, the traces of ancient supernovae are present in the very composition of its clouds. Astronomers have detected an unusual abundance of certain heavy elements in the region, suggesting that previous stellar explosions contributed to seeding that space with enriched dust. Why is this important? Because without these materials, rocky planets like Earth could not exist, as the key elements for their formation are only obtained in the cores of stars that eventually explode. Therefore, in a sense, every atom of iron in our blood was once part of a star that died in a supernova. How does this enrichment influence star formation? When the gas and dust enriched by supernova mix and cool, they they can collapse under their own gravity and give rise to new stars. This process is similar to recycling materials in a factory. The remnants of a previous generation of stars become the raw material for the next. Additionally, the shockwave from a supernova can compress nearby gas clouds, acting as a trigger that initiates the formation of new stars. It's as if an explosion in space not only destroys, but also provides the necessary push for new lights to emerge from the darkness. And what does all this tell us about our place in the universe? The Orion Nebula is a living example of how the cosmos constantly renews itself, using the remnants of ancient stars to create new ones. This cycle of destruction and creation is fundamental to the evolution of galaxies and the existence of habitable planets. Thus, every time we look towards Orion, we are witnessing the result of billions of years of explosions, mixing, and stellar rebirths. Who would have thought that, at the heart of a nebula, the chaos of a supernova could be the beginning of everything we know? Where do planets come from? How is it possible that amidst a chaotic cloud of gas and dust, entire worlds emerge, perhaps with oceans and mountains? The answer lies in the protoplanetary disks that form around young stars within the Orion Nebula. When a new star is born from the gravitational collapse of a dense region, it does not do so alone. Around it remains a swirl of material. This disk, composed mainly of gas and tiny solid particles, is the breeding ground where planets begin to take shape. The formation of planetary systems is a process that combines order and chaos. Within the disk, dust particles start to collide and stick together, forming increasingly larger bodies. It's as if hundreds of millions of snowflakes cluster together to create giant snowballs, which then continue to grow into rocks and later into protoplanets. But how do these particles, so small and dispersed, manage to unite in such a violent environment? Gravity and static electricity play fundamental roles. They attract and bind the dust, allowing planetary embryos to gain mass and evolve. As these bodies grow, their gravity increases and they begin to attract more material from the surrounding disk. Some will become large enough to accumulate a gaseous atmosphere, turning into giants like Jupiter, while others will remain rocky worlds. The environment within the Orion Nebula is especially conducive to this process, as both gas and dust are abundant. However, the powerful radiation and stellar winds from the most massive stars can also disperse the material, limiting the time available for planets to fully form. Thus, the race to build new worlds is a constant struggle against the cosmic clock. Could these protoplanetary disks harbor future planetary systems similar to ours? Observations indicate that in the Orion Nebula, there are hundreds of these disks at different stages of evolution. In some, gaps and structures have already been detected that suggest the presence of forming planets. Studying this process in Orion not only helps us understand how planets are born, but also unravels the history of our own solar system, and perhaps that of other systems where life might one day emerge. How do we know that planets are forming in distant places like the Orion Nebula? The answer is a combination of human ingenuity and cutting-edge technology. Astronomers cannot directly observe a newborn planet, as these bodies are still enveloped in dense disks of gas and dust. However, they have developed indirect methods to detect their presence from hundreds of light years away. One of the most fascinating techniques involves observing so-called protoplanetary disks, rings of material that rotate around young stars. When a planet begins to form within these disks, its gravity carves out grooves and gaps, as if a spoon were stirring a cup of frothy coffee. These imprints can be observed at different wavelengths, especially in the infrared and microwave ranges, thanks to telescopes like ALMA and the James Webb. What signals are scientists specifically looking for? A key clue is the gaps and rings within the disks, which suggest that a massive object is clearing its orbit. Additionally, jets of material expelled at high speeds can be detected, indicating that there is intense activity in the region. Irregular movements in the gas, observed through spectroscopy, also reveal the presence of forming bodies. It's like trying to deduce the presence of fish beneath the surface of a lake, not by seeing them directly, but by the waves and ripples they leave as they swim. Have planets in the process of formation been found in the Orion Nebula? Yes, and they are revolutionary discoveries. A prominent example is the so-called proplyds, tiny droplets of gas and dust illuminated by nearby stars. Within these structures, astronomers have identified regions where material begins to condense and collapse, giving rise to new worlds. In some cases, they have even detected thermal signals that could correspond to the heat released by young planets as they absorb material from their surroundings. Why is it so important to detect forming planets in Orion? Because it allows us to observe, almost in real time, the same processes that gave rise to Earth and the rest of the planets in the solar system billions of years ago. Analyzing these systems in their early stages helps us understand how planets are assembled, how factors like radiation from nearby stars influence them, and what conditions favor the emergence of potentially habitable worlds. Thus, the Orion Nebula is not only a natural laboratory for astronomy, but also a window into the past of our own cosmic home. Have you ever wondered how our solar system was formed? What if I told you that, thousands of light years away in the Orion Nebula, we are witnessing processes very similar to those that gave rise to Earth, the Sun, and all the planets around us? The Orion Nebula is much more than a cloud of gas and dust. It is a true natural laboratory where astronomers can observe, almost as if they had a time machine, the same steps that our solar system likely went through over 4 billion years ago. At the heart of the Orion Nebula, young stars are born, surrounded by disks of material, known as protoplanetary disks. These disks are true factories of planets, just like the disk that surrounded the Sun in its first million years. What happens in those disks? Dust and gas begin to clump together, collide, and merge, forming everything from tiny grains to planetary embryos. This process, called accretion, is the same one that gave rise to the planets of the solar system, including Earth, Mars, and Jupiter. Thus, observing Orion is like looking at a cosmic, large-scale version of our own past. But the similarities don't end there. In the Orion Nebula, scientists have detected the presence of complex organic molecules, such as water, carbon monoxide, and even prebiotic compounds. These substances, essential for life as we know it, were also present in the original cloud that formed the solar system. Is it possible that the ingredients for life are common in star-forming regions? Everything seems to indicate that yes, and this opens the door to an even more fascinating question. Could the planetary systems in Orion one day harbor life like ours? Moreover, the intense radiation emitted by the most massive stars in Orion shapes the protoplanetary disks and can even evaporate part of the material, a phenomenon that also affected the nascent solar system. Some scientists believe that the presence of nearby massive stars may have influenced the composition and architecture of our solar system, determining how many planets formed and what type they were. Thus, by studying the Orion Nebula, we not only learn about the life and death of stars, but we also unveil the secrets of our own origin, and perhaps that of countless worlds beyond our own. What enigmas does the Orion Nebula still hide? Although science has managed to unravel many of its secrets, this stellar nursery continues to challenge astronomers with fascinating questions. For example, one of the greatest mysteries is how exactly the rates of star formation spike at certain times and places within the nebula. What triggers these waves of star birth, and why do they seem so unpredictable? Scientists suspect that shock waves, caused by massive stars or even by ancient supernova explosions, could play a key role, but understanding the precise mechanism remains a challenge. Another intriguing question revolves around the formation of planetary systems in such chaotic environments. If interstellar material is constantly being stirred, eroded, and reconfigured by radiation and stellar winds, how do protoplanetary disks manage to survive long enough to form planets? Are there protected zones, or are there unknown processes that allow matter to condense and evolve despite the extreme conditions? Solving this mystery would not only help understand the origin of other planetary systems, but also that of our own solar system. The Orion Nebula also raises questions about the actual role of complex organic molecules in the formation of life. Prebiotic compounds have been detected in its clouds, but how do they form exactly under intense ultraviolet radiation? Can these materials survive and travel to new planets, seeding the basic ingredients for life? The answer to these questions could bring us closer to understanding whether the processes that gave rise to life on Earth are common throughout the universe. Finally, the internal dynamics of the nebula remain a puzzle. Why do certain structures, like the famous proplyds, appear and disappear on such short timescales? What role do gas cloud collisions and gravitational interactions play in the creation and destruction of these ephemeral forms? Each new observation reveals unexpected details, reminding us that the Orion Nebula is a living laboratory where the most extreme physics and the most delicate processes intertwine, and where surprising discoveries still await us. What role can a single nebula play in the gigantic story of a galaxy? The Orion Nebula is not just a light show in the vast universe, it is a key cog in the evolutionary machinery of the Milky Way. To understand its importance, one must first imagine the galaxy as a living organism, where nebulae like Orion are the organs responsible for giving birth to new generations of stars. Without these cosmic incubators, the galaxy would lose its ability to renew and evolve. Now, what happens when a region produces stars at an intense rate like Orion does? Each young star, especially the more massive ones, influences the interstellar environment with its radiation and stellar winds. These elements not only sculpt the nebula itself, but also disperse heavy elements into the surrounding space. Thus, Orion acts as a chemical factory, enriching the galactic medium with essential materials for the formation of future generations of stars, planets, and even complex molecules necessary for life. But how does this local process connect with the large-scale evolution of the galaxy? The life cycle of the stars born in Orion, from their formation to their death, fuels the dynamism of the Milky Way. When the largest stars explode as supernova, they release energy and materials that stimulate new waves of star formation in nearby regions. It's like a chain of campfires igniting one another over millions of years, keeping the galactic cycle in constant motion. Finally, one might ask, what would our galaxy be like without nurseries like Orion? The answer is simple. It would be a much more static place, lacking diversity. Nebulae like Orion not only contribute beauty and mystery to the sky, but are essential for the vitality and evolution of the entire galaxy. Orion is, in essence, one of the great engines that keep the spiral of the Milky Way alive, reminding us that even on such a vast scale, the birth and death of stars are fundamental to the cosmic story. Is it possible for the same nebula to reveal different secrets depending on how we observe it? The Orion Nebula is a perfect example of how the universe hides layers of information that are only unveiled when we look beyond visible light. While our eyes only capture a small fraction of the electromagnetic spectrum, astronomers use a variety of specialized telescopes to explore the nebula in wavelengths as diverse as infrared, ultraviolet, and radio. Each of these windows allows us to discover details that would otherwise remain hidden, as if we were exploring a dark mansion with different flashlights, each revealing different rooms and passages. What does infrared show us that visible light cannot reveal? Infrared observations are essential for exploring the interior of the Orion Nebula, as this wavelength can penetrate the interstellar dust that blocks conventional vision. Thanks to telescopes like Spitzer and James Webb, scientists can detect protostars, protoplanetary disks, and star-forming regions that would otherwise be completely concealed. In fact, infrared allows us to see the birth of stars and planets in real time, as if we were observing a secret garden behind a curtain of smoke. And what happens when we look at it in ultraviolet? Ultraviolet radiation is primarily emitted by the youngest and hottest stars in the nebula. And by observing in this wavelength, astronomers can study how the intense energy of these stars ionizes the surrounding gas, This ionization is responsible for the characteristic brightness of the nebula and the spectacular colors we see in processed images. Moreover, ultraviolet reveals details about the energetic processes that sculpt the whimsical shapes of the nebula and regulate the evolution of forming planetary systems. What secrets are hidden in radio waves? Although it may seem incredible, the Orion Nebula also emits signals in radio wavelengths, which can be detected by radio telescopes from Earth. Through these observations, astronomers can trace complex molecules, map the distribution of cold gas, and study the internal movements of molecular clouds. Radio waves allow us to discover even deeper and colder regions, where future generations of stars are being born, and provide clues about the presence of essential prebiotic compounds for life. Can we imagine the wealth of information obtained by combining all these wavelengths? It's like piecing together a multi-dimensional puzzle of the cosmos, where each piece adds a layer of understanding. Observing the Orion Nebula in different wavelengths not only expands our knowledge about this stellar nursery, but also demonstrates how the universe is much more complex and fascinating than what the naked eye can capture. Each frequency tells us a different story, and together they form an astonishing narrative about the birth of stars and planets. What do an interstellar gas cloud and the origin of life have in common? It may seem like nothing, but the Orion Nebula hides a fascinating answer. Although no living microorganisms have been detected in this vast stellar nursery, astronomers have found something that could be considered the first step toward life: prebiotic molecules. But what does this really mean? Prebiotic molecules are complex compounds, such as amino acids and simple sugars, that can serve as fundamental building blocks for life as we know it. Their presence in the Orion Nebula suggests that the essential ingredients for life are not only formed on planets, but may also arise in deep space, long before a world exists where they can thrive. Now, how do these molecules manage to form in such a hostile environment as a nebula? The key lies in the dust and interstellar gas, which act as a natural laboratory. Dust particles serve as tiny scaffolds on which atoms and molecules assemble at extremely low temperatures. Imagine millions of small laboratories floating in space, where radiation and chemical reactions shape increasingly complex compounds. In fact, molecules such as formaldehyde, methanol, and hydrogen cyanide have been detected in the Orion Nebula, all considered precursors to the chemistry of life. Could the Orion Nebula then be a galactic factory for the ingredients of life? The evidence points in that direction. Young stars and their protoplanetary disks, which form within the nebula, inherit this rich chemical cocktail. As these disks evolve and begin to generate planets, some of that prebiotic material becomes trapped within them, traveling millions of light years to perhaps find a suitable environment for the emergence of life. Some scientists compare this process to a cosmic seeding. The galaxy distributes key molecules in different corners, increasing the chances that life may emerge in more places in the universe. Are we alone in the cosmos, or are the seeds of life scattered everywhere? Although microorganisms have yet to be found in the Orion Nebula, the discovery of prebiotic compounds is a powerful clue. It reminds us that life, in its most elemental form, could be the result of common processes in the universe. Each complex molecule detected in Orion is a chemical message inviting us to imagine that, in some other corner of space, those pieces could assemble to form the first living beings. Thus, the Orion Nebula is not only a garden of stars, but also a possible natural laboratory where the first steps toward life are rehearsed. Is it possible that a nebula like Orion holds clues about the origin of life beyond our planet? This question has fascinated both astronomers and astrobiologists for decades. The Orion Nebula, with its vast natural laboratory of gas and dust, is one of the places in the cosmos where the basic ingredients for life are actively at work. But what makes this corner of the universe especially interesting for those searching for traces of life on other worlds? At the heart of the nebula, telescopes have detected complex organic molecules, some similar to those that form the basis of living beings on Earth. How is it possible that, in a cloud of gas and dust, precursor compounds of life emerge? The answer lies in cosmic chemistry. The ultraviolet radiation from young stars breaks and reforms molecular bonds, allowing the creation of molecules like methanol, formaldehyde, and even simple amino acids. This process may sound like a cosmic cooking recipe, where elements mix and transform under extreme conditions, paving the way for life to be possible elsewhere. Astrobiology studies precisely these scenarios, environments where essential ingredients come together and transform, just as happens in the Orion Nebula. If we think about the formation of planetary systems within the nebula, the question arises, could these emerging worlds inherit the prebiotic molecules present in their parent cloud? Evidence suggests that they can. Protoplanetary disks, rich in dust and gas, contain these compounds, which can adhere to ice grains and travel to forming planets, much like a message in a bottle cast into the cosmic ocean. And what implications does this have for the search for life beyond Earth? If the basic elements for life are present in regions like Orion, the possibility that planetary systems in other corners of the galaxy also possess them becomes much more likely. Each new observation reinforces the idea that life, in its simplest form, may not be a rarity, but rather a natural consequence of the chemical evolution of the universe. The Orion Nebula, then, is not just a garden of young stars, but also a natural laboratory where the first steps toward life in the cosmos are explored. What happens when we observe an object as seemingly static as a nebula for years, decades, or even centuries? The answer may surprise you. The Orion Nebula is far from a motionless picture in the sky. On the contrary, it is a constantly changing stage, a cosmic laboratory where phenomena of variability abound, challenging our perception of time and space. Can a cloud of gas and dust change its appearance or behavior from one year to the next? Yes, and astronomers have patiently confirmed this with technology. One of the most fascinating phenomena is the variability of the light emitted by the nebula. This variability comes not only from young stars, which pulse and fluctuate in brightness like cosmic beacons, but also from entire regions of ionized gas. For example, some areas of the nebula light up or dim slightly over the years due to changes in the radiation they receive from nearby stars. It's a similar effect to that of terrestrial clouds, which, as they pass in front of the sun, change the lighting of a landscape. In Orion, however, these light shows can last for years or decades and reveal dynamic processes occurring within the cloud. What about the internal movements? The nebula is a massive hive of activity. Jets of gas ejected by protostars can change direction and brightness, as if they were cosmic fireworks in slow motion. Shock waves, caused by stellar winds or past explosions, move through the gas, altering densities and temperatures. Bubbles of gas have even been observed slowly expanding, as if the nebula were breathing. These changes, although imperceptible to the naked eye, have been captured thanks to long-term observations and show that Orion is anything but static. Variations in protoplanetary disks also stand out, those rings of material surrounding young stars that could form planets in the future. Some of these disks show eclipses, sudden increases in brightness, or, conversely, unexpected dimming. Scientists suspect that these changes may be due to the presence of forming bodies, such as planets or large clumps of dust, passing through the disk and blocking the light. It's like watching the shadow of a leaf move over a lamp. Small variations can reveal big secrets about what's happening inside. Finally, researchers have detected changes in the chemical composition of certain regions, likely related to the emergence of new stars and the destruction or formation of complex molecules. All of this demonstrates that the Orion Nebula is a dynamic ecosystem where variability is not the exception, but the rule. Observing these phenomena is like watching a cosmic movie in slow motion. Every detail, every change, contains clues about the birth and evolution of stars and planets. How many new mysteries will the next observation reveal to us? The answer continues to be written every night, in the heart of Orion. What invisible force can sculpt entire clouds of gas and dust into shapes as complex and dynamic as those we see in the Orion Nebula? The answer is gravity, the silent and persistent engine that drives the fate of every particle in this colossal stellar nursery. Gravity not only holds together the vast clouds that form the nebula, but it is also responsible for initiating the very process of star formation. Without the action of this fundamental force, interstellar gas and dust would simply float scattered, never coming together to form new stars or planets. So why does gravity play such a crucial role in the evolution of structures like the Orion Nebula? When small irregularities in the density of the gas create slightly denser regions, gravity begins to exert its influence, pulling even more matter toward those points. It's as if the nebula were an ocean of dust, and gravity, a marine current slowly dragging everything toward whirlpools where new stars will be born. These whirlpools, known in astronomy as collapse cores, are the first step in the formation of a star. Matter is compressed, increasing pressure and temperature until nuclear fusion finally ignites. As gravity continues its work, it not only forms stars, but also shapes the overall structure of the nebula. Large clusters of young stars, like the famous trapezium, can alter their surroundings with their own gravity, generating shock waves that compress the surrounding gas and trigger more episodes of starbirth. This perpetual cycle turns the nebula into a stage of gravitational interactions, where each new star has the potential to influence the formation of others, in a kind of cosmic domino effect. Is gravity the only protagonist in this astronomical drama? While there are other forces at play, such as radiation pressure and stellar winds, none have the universal reach of gravity. This invisible power not only determines the fate of the nebula, but also lays the groundwork for the formation of planetary systems and even the eventual dispersal of the remnants of the cloud. Ultimately, gravity is the silent sculptor that transforms chaos into order, allowing stars, planets, and perhaps life to emerge from simple atoms of hydrogen and dust in some distant corner of the universe. What happens when the gigantic clouds of gas and dust inside the Orion Nebula collide with each other? Far from being a static and silent space, the heart of this nebula is a dynamic stage where the titanic forces of nature clash in a chaotic and creative dance. The collisions between molecular clouds may seem at first glance like destructive events, but in reality, they are the engine that triggers new cycles of stellar birth. When two of these clouds meet, their masses compress, and under immense pressure, regions of gas begin to collapse, giving rise to new stars. It's as if two cold and warm fronts collide in the Earth's atmosphere and unleash a storm, except here the storm produces suns. How do these collisions affect the internal evolution of the nebula? The violent interactions between clouds not only favor star formation, but also generate shock waves that travel through the interstellar gas at supersonic speeds. These waves act as cosmic sculptors, compressing some regions and dispersing others, creating cavities, filaments, and complex structures within the nebula. The energy released in these encounters can heat the gas, alter magnetic fields, and trigger turbulence, causing the nebula to be in constant transformation. But what role do young, massive stars play in this dance of interactions? Upon birth, these stars do not remain indifferent to their surroundings. Their strong stellar winds and the radiation they emit impact nearby clouds, triggering new waves of shocks and internal movements. It is a feedback cycle. Collisions form stars, and stars, in turn, modify the environment, causing more collisions and reorganizing interstellar material. Thus, the Orion Nebula becomes a natural laboratory where the basic ingredients of matter mix, collide, and recycle endlessly. Finally, why is it so important to study these dynamics? Understanding the collisions and internal movements of the Orion Nebula gives us essential clues about how stars and planetary systems form and evolve in the universe. The patterns we observe here may repeat in other regions of the galaxy, and perhaps in some distant corner, they are giving rise to solar systems like ours. Thus, the collisions and internal dynamics are not just chaotic phenomena, they are the very heartbeat of cosmic life, marking the rhythm of creation in the vast stellar garden of Orion. What do a science fiction blockbuster, a romantic poem, and a modern painting have in common? The answer might surprise you. The Orion Nebula, this gigantic stellar nursery, has fascinated humanity since time immemorial, and like a cosmic magnet, has attracted artists, writers, and filmmakers from all eras. Why have so many creative minds been inspired by a cloud of gas and dust located over 1,000 light-years from Earth? The answer lies in its mystery and beauty, which seem to defy the limits of our imagination. In cinema, the Orion Nebula has been much more than just a starry backdrop. Do you remember the iconic line from the replicant Roy Batty in Blade Runner when he says, "I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion?" That moment turned the nebula into a symbol of the unknown, of the unattainable, and of the limits of human experience. It is no coincidence that many science fiction stories place aliens, advanced civilizations, or star portals near this region of the sky. Orion represents a frontier, a place where the real and the imaginary merge. Literature has also found a powerful symbol in Orion. In Greek mythology, Orion was a giant hunter, and his figure was immortalized in the sky. But beyond ancient myths, modern poets and novelists have used the nebula as a metaphor for birth, transformation, and hope. What would it be like to observe the universe from a place where stars are born? Some authors suggest that contemplating the Orion Nebula is peering into the workshop where the dreams of the cosmos are forged, a reminder that even in the deepest darkness, new light can emerge. And what about visual art? Painters, illustrators, and photographers have tried to capture the complexity and colorfulness of the nebula. Its ethereal shapes and vibrant tones challenge the limits of the traditional palette, forcing artists to reinvent the way they represent the celestial. The Orion Nebula appears in murals, album covers, and even tattoos as an emblem of the sublime and the unknown. Why do so many people choose to carry a piece of Orion on their skin or on the wall of their room? Perhaps because deep down, we all feel an ancestral connection to the place where stars are born. The influence of the Orion Nebula on popular culture is as vast as the universe itself. From songs that evoke its name to video games that transport players to its confines, this cosmic cloud has become a bridge between science and art, between reality and fantasy. In the end, the Orion Nebula is not just an astronomical phenomenon, it is a symbol of our eternal quest for answers and of the human capacity to dream beyond the visible. Is that why, generation after generation, we continue to look to Orion for inspiration? How often are we surprised by astronomical research? The Orion Nebula is no exception. In recent years, astronomers have focused their most advanced telescopes on this stellar nursery, revealing details that once seemed unattainable. Did you know that the James Webb Space Telescope managed to capture structures and movements of gas and dust with unprecedented precision? This level of detail has allowed for the identification of newly born protostars and the analysis of protoplanetary disks at such early stages that until recently, we could only imagine their existence. What mysteries have these recent studies solved? For example, infrared observations have managed to penetrate the dense clouds of dust, showing how the radiation from young stars shapes and sculpts the nebula. The presence of complex molecules, such as methanol and other prebiotic substances, has been detected, suggesting that the ingredients for life may be present from the earlier stages of star formation. Additionally, it has been observed how intense stellar winds and jets of material ejected by newly formed stars generate turbulence and new shockwaves, triggering the birth of new generations of stars. Who is leading this race for knowledge? International teams, combining data from the Hubble telescope, the ALMA Observatory in Chile, and the James Webb itself. are working together to create three-dimensional maps of the nebula. These maps allow for the visualization of the distribution and movement of gas and dust, revealing areas of active star formation and regions where processes seem to stall. Why do some regions generate stars at a frantic pace, while others remain almost inert? Answering this question is key to understanding the life cycle of galaxies. And what does the immediate future hold for us? With each new observation, new questions arise. The discovery of microstructures within protoplanetary disks, which could be related to the formation of giant planets, has opened debates about how and when planetary systems are born. Signals of variability have even been detected in certain protostars, as if they were beating or pulsating, prompting a re-evaluation of stellar evolution models. The Orion Nebula remains a fundamental natural laboratory for modern astronomy, where each technological advance opens an even deeper window into the origin of stars and perhaps of life itself. What does the future hold for the exploration of the Orion Nebula? Despite advancements with telescopes like Hubble and James Webb, astronomers have barely scratched the surface of the mysteries contained within this stellar nursery. Today, technology is advancing by leaps and bounds, allowing us to imagine a new era of discoveries. For instance, what if we could witness the birth of stars and planets with an unprecedented level of clarity? That question drives the development of increasingly powerful instruments capable of capturing details unimaginable just a few decades ago. One of the most ambitious projects is the Extremely Large Telescope, known as ELT for its acronym in English. This colossus, currently being built in the Chilean Atacama Desert, will feature a mirror nearly 40 meters in diameter. To put it in perspective, it's like comparing a pocket magnifying glass to a panoramic window. The amount of light it will be able to collect and the resolution it will achieve will allow us to observe the Orion Nebula with an unprecedented level of detail. Will we discover new protostars hidden in the depths of interstellar dust? Will we witness the formation of planets in real time? Moreover, the future of observation is not only on Earth. Space will be the stage for even bolder missions. The next generation of space telescopes, such as the Nancy Grace Roman and future proposals like LUVOIR, are designed to analyze the light from the Orion Nebula at even more extreme wavelengths. These tools could identify complex molecules, track the evolution of protoplanetary disks, and perhaps detect the first signals of organic compounds essential for life. What new clues about the origin of planetary systems and prebiotic chemistry will we uncover? Artificial intelligence will also play a crucial role in analyzing the vast amounts of data these instruments will generate. Sophisticated algorithms will help detect patterns, predict the evolution of structures, and alert us to transient phenomena that might go unnoticed by the human eye. Thus, the collaboration between technology, science, and human curiosity will open an ever-growing window into the heart of the Orion Nebula. Could any of the upcoming discoveries completely change our understanding of the birth of stars and our own cosmic origin? The future of astronomical observation promises answers, but above all, new questions that invite us to continue exploring the universe. What secrets does the Orion Nebula hold for modern astronomy? This gigantic cloud of gas and dust is not just a visual spectacle, but a natural laboratory where astronomers can study, almost in real time, the fundamental processes that give rise to stars and planets. By observing the Orion Nebula, scientists have learned how a simple accumulation of hydrogen can trigger a chain reaction that ultimately ignites new stars. It's like witnessing the first chapter of a cosmic novel, where seemingly chaotic matter organizes and shapes entire systems. Why is it so valuable for understanding our own origin? In Orion, astronomers have confirmed that the processes occurring there are not exclusive to that region, but universal models of star formation. The protostars wrapped in disks of dust and gas closely resemble what our Sun would have been like billions of years ago. By analyzing protoplanetary disks, key stages for planet formation have been identified, revealing that worlds like Earth can emerge under similar conditions in other parts of the galaxy. Thus, the Orion Nebula acts as a time machine, showing scientists how our own solar system may have begun. How are the stars born in Orion connected to the rest of the universe? A crucial lesson is the recycling cycle of matter. From supernova explosions and stellar winds, heavy elements are dispersed and enrich the nebula, providing the necessary ingredients for new generations of stars and planets. It serves as a reminder that the universe is dynamic and constantly transforming. In fact, the complex chemistry detected in Orion, including organic molecules, suggests that the basic building blocks of life may be present from very early stages in the evolution of planetary systems. But what does all this imply for the search for life and our understanding of our place in the cosmos? Orion has taught astronomy that the processes of creation and destruction are universal and cyclical. The nebula not only shows how stars are born, but also how the essential materials for life die and are reborn. Each observation and every piece of data collected in this region brings us closer to answering fundamental questions. Is life a common phenomenon in the universe? Are there other systems similar to ours waiting to be discovered? The Orion Nebula, in its majesty and mystery, continues to guide science in the quest for answers that, until recently, seemed unattainable. What makes the Orion Nebula one of the most fascinating places in the known universe? At the heart of our galaxy, this gigantic cloud of gas and dust acts as a true cosmic laboratory, creating new stars and planetary systems from the same ingredients that, billions of years ago, formed our Sun and Earth. But can we really imagine the magnitude of the processes occurring there? The Orion Nebula is the stage for an incessant dance between gravity, radiation, and chaos, where matter transforms and gives rise to new generations of celestial bodies. Why has Orion captured the attention of scientists and dreamers throughout history? Perhaps because within its depths lie some of the keys to our own origin. The elements that compose life, such as carbon, oxygen, and hydrogen, combine and evolve in this stellar nursery, forming complex molecules that, in some corner of the cosmos, could give rise to new forms of life. Thus, Orion is not only a visual spectacle, but also a bridge to fundamental questions. Are we the result of a common process in the universe? Or is our existence a rarity amidst the infinite? The Orion Nebula teaches us that the universe is a place of constant change and creation. Astronomers observe how the birth and death of stars enrich the space with new materials, feeding a perpetual cycle of destruction and rebirth. Who would have thought that dark, cold dust could be the starting point for radiant stars and entire planetary systems? In this sense, Orion is a reminder that even in the most inhospitable places, life and light can find their way. How far can we go in our understanding of this colossal garden of stars? With each new telescope and every technological advance, we unveil a little more of its secrets, but new questions always arise. What mysteries await in the most hidden corners of the nebula? Will we ever witness the birth of a planet similar to ours? Orion invites us to look up and keep curiosity alive, reminding us that in the search for answers, the universe always has new wonders to offer.